Hello, 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 hello. Okay, I'm here. Let me check if I'm recording. Yes, I'm recording. Hello. Okay, everybody. I hope you hear me well. I'm going to answer some questions about fractions, ratios. We're going to see some things of coordinates, maybe something of geometry in the questions that I can cover from this week. So you just need to let me your questions by Instagram, TikTok, Facebook, whatever the media you want, and I will try to answer all the questions during today. In this case, I'm going to use this live session to work out on basic mathematics. I received a question about physics that it's pretty interesting, but I think that I need to study more to have the answer of this question. So when I have the answer of this question, I will send a video. I think that is more for a long video than solving this type of questions. So I'm going to start today with some basic question about how to divide a fraction, how to divide two fractions. And the question is this: 5/8 divided 5/8 divided divided 350 412 350 412. Now this is a basic operation of fractions, but we need to be careful when we operate this type of fractions, because if you try to do like any other method, maybe it's going to take you a lot of time, or you're going to perform longest multiplications in this case. So the first thing we're going to do is that just remember that when you multiply by but when you divide fractions, you're just multiplying by the reciprocal. So essentially what we're doing is just multiplying the reciprocal. I mean, the reciprocal is just interchange numerator and denominator. So what I'm going to do is just interchange numerator and denominator. And now I'm going to simplify or divide by common factors. That is the strategy I prefer to use. That is applying that if I have a numerator, I'm going to find out common factors with any of the denominators to simplify them before we multiply numerators. Here in this case, I can divide this 5 by 5 to get 1, and I can divide this 350 by 5 to get 70. 35 divided by 5 is 7, and as is multiplied by 10, I just need to move the 0 down. Okay, now in this case I already have like the division. Now I can continue dividing. For example, I can divide by 2 412, or maybe we can go further and you can divide by 4 412, and if you divide by 4 412, you're gonna get 4 divided by 4, that is 1, and here 0, and here 12 divided by 4 is 3, so I got 103, and the 8 divided by 4 is going to be 2. Okay, so I already have 103 and I have 2. I think that it's no more way to divide these two numbers, so essentially what I'm going to do is just multiply the factors that I got here. That is 1 times 103, I got 103, and here 2 times 70, that is 350. Sorry, that is 140. I'm sorry, what is the eraser here? Well, there's no eraser here. Oh yes, it's here. Sorry, I was thinking on times 5. Okay, so 2 times 70 is going to be 140. And in this case, I already have my numbers in simplest form. So as you can see here, you can observe how to divide without operating first the numbers. Now, can I do it like directly? 5 times 412 and 8 times 350? Of course you can do it and then simplify the fraction. But the problem is when you simplify the fraction, what you're going to do, because it's going to take you a lot of time to divide by common factors. Okay, in this case the common factor is 20. So you have to identify the common factor first before dividing. Okay, that's it. This is how you operate fractions. This was the first question, like how you can perform this type of operations. So this is the structure, this is the idea, this is the answer. The first question right now is answered. Let's go to the second question. I think I can, maybe I can erase directly. Oh, here. Yes. Hello. No, I can erase it. Let's see if I can do it again. Bye bye. Okay, everybody, I couldn't do it. Okay, Miguel, I'm trying to erase this. I'm going to answer another question. That is about coordinates. How can I know whether, when I plot coordinates, how can I know how to plot coordinates on a Cartesian plane? I guess that is on a Cartesian plane. So let's go to a Cartesian plane here. Okay, I'm going to a Cartesian plane here. Let's explore geometry maybe. Okay, so let's create a Cartesian plane. Let's create a Cartesian plane. Okay, so we have here a Cartesian plane. I hope you can see the Cartesian plane. Now, the idea of working on Cartesian planes or plotting data, you need to understand that here we're having usually two numbers, let's say numbers, that represents the coordinate that it's giving you. And the coordinate, it's going to, you need to show a way to provide a reference of this coordinate. Now, by notation, we're going to put first in our coordinate the independent variable or the horizontal axis. And then you're going to show the dependent variable or the vertical axis. So the main idea is that you understand that first we're going to put let me see if I can find here. Yes. So here I'm going to put dependent variable, and here I'm going to put independent variable. Okay, so this is what you do when you provide on a Cartesian plane coordinates. Now, if I'm going to put a point on a Cartesian plane, so I need to provide information of the independent, then the dependent variable. So it means that I'm going to put, for example, I'm going to tell 3, then 5. So it means independent x and dependent y. So I'm going to put my coordinate 3, 5 means that I need to move 3 units in the horizontal axis and 5 units in the y-axis. So it's going to be like the independent is going to be 3, the dependent is going to be 5. Now it means that always x is independent and y is dependent. When you're plotting on a coordinate plane, setting x horizontal and y vertical, yes. Yes, sometimes x is going to be dependent variable from another independent. So you put the independent horizontal and the dependent vertical. This is notation. But in plain terms, for any Cartesian plane in mathematics, we put coordinates in a way that in the x-axis, we put first, by notation, we select first the x-axis coordinate and then the y coordinate. This is the second question about coordinates. Let's see if there's another question related to plotting data in graphs. Okay, there is something interesting when you plot data. And let's say that you plot 3 points. I'm going to put 3 points on, could be here and here. Okay, let's see that you have these 3 points setting on your graph. You already plot these points. So for example, this point B, is going to be the point 1 and 3. Okay, it's going to be, this is the point 1 and 3, and this is going to put the point 2 and 4. Okay, and this is 3, 5. Okay, you can put it like in a table or something like that. But so far, what I'm going to do when plotting data is that you can provide a straight line, in this case, a straight line, that follows the pattern of these 3 points, correct? So I'm going to follow a pattern with these 3 points. These 3 points follows a linear pattern. And the idea is, how can I know if these 3 points that, or the question itself is, how can I know the criteria to understand whether these 3 points follows, or this relation 1, 3, 2, 4, 3, 5 follows a direct variation or not? I mean, if x and y in this case are directly proportional. So I'm going to write here the data. Let me see if I can have an eraser here. I don't remember. No, I don't think I have an eraser here, so I have to erase by selecting. Bye-bye. 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 Okay. Bye. Bye. Okay, so I want to know whether this relation, these points, so let's say x and y, that are given by 1, 3, 2, 4, and 4 and 3, 5. I want to know if this relation is directly proportional, if they follow a direct variation. How can I know if a relation is directly proportional or not? If you're in a graph and plot the points, the first rule to know if they are directly proportional, the first rule is that they have to match with a straight line. So in this case, I can think that maybe it's probable that they are directly proportional because they match to a straight line. And the second is that the straight line must cross by 0, 0, by the origin. In this case, our line does not cross the origin, cross the point 0, 2. So it crosses by 0, 2. So as it doesn't pass by 0, 0, it means that this relation is not directly proportional because it doesn't cross by 0, 0. Now, it's a straight line. Yes, it may be directly proportional. Maybe you can make it directly proportional if you change the values of x. But, however, if we're very strict in our situation, if we're very strict, these aren't directly proportional. Okay, this is not directly proportional. X and y aren't directly proportional because they don't pass by 0, 0. Now, what happens if two magnitudes are directly proportional? If two magnitudes are directly proportional, means that the ratio of these magnitudes is constant. It's going to be constant. And if the ratios of these two magnitudes are constant, then I can follow a direct variation to solve the problem, to find out any y or any x by giving the other variable. And I can use a common ratio strategy, or I can use proportions to solve. So in this case, let's go again. Let's say that I take the ratio y to x. So I'm going to take y to x. I divide 3 over 1, so I'm going to get 3. 4 over 2, 4 to 2. So this is 3 to 1. 4 to 2 is going to give me, if I simplify the dividing by 2, is going to give me 2 to 1. And in this case, 5 to 3. As you can observe, these ratios here are not constant, are not the same ratio. So as they are not the same ratio, I cannot say that they are directly proportional. I cannot use direct variation to find any value of y and x. Let's say that I want to know what happened when x is 25. So I cannot use direct variation to find out this. Now, what happened in other cases? Let's put a case in which they are directly proportional. In this case, it's not directly proportional, but let's try to get a value in which is directly proportional. Okay. I need to erase all of this. Give me a minute. Let's erase it. Okay. So now we already know that this is not directly proportional, but what happens if we put a directly proportional pattern? I'm going to put 3 points in a way that they are directly proportional. Now the good thing here is that I already create a line, so I just need to move one of these points in a way that I make it directly proportional. For example, here, let's say I'm going to put 2 points here, let's say here. Okay. I think I can make it. Maybe if I move it here. Okay, I'm just trying to get directly proportional patterns. Now I got mixed with information. Okay, here it's a directly proportional pattern, although it's an easiest pattern. Maybe I can do it like more difficult. Maybe no. Okay, let's use this one. Let's use this example, so we don't take a lot of time talking about how to put the numbers here. Now here is the idea. I have these patterns. Now I'm going to put x and y. Remember that x is the vertical axis. In the coordinate, it's going to be the one who goes first. X and y. So in this case, I'm going to have 2 with 2, 4 with 4, and 6 with 6. This is like the identity, right? Because the ratio of y to x is 1. 4 over 4 is 1. 6 over 6 is 1. So in this case, the ratio is the same. What happened, for example, if I want to do I want to create like a directly proportional pattern, and I know that let's erase this. Okay, I know that let's say that this is 5 with 4, and I'm going to make it like a line that crosses by 0, 0. Okay, I have the line that crosses by 0, 0. Look, and point A, I'm going to put it in 6. Okay, let's say that you have this straight line, and in this straight line, I know only one coordinate. I only know that the coordinate when x is 4 is that y is 5. So it means that the ratio y to x is 5 to 4. Okay, I know this from the graph. And I have the value. I want to know what happened when x is 6 and when x is 2 because I cannot see what is the value. As the ratio is the same, I can apply direct variation. So it means that if I have here 2, let's say that the unknown is a, and when I have 6, let's say that the unknown is b. So if as I can apply direct variation, you just can operate by applying our strategy of proportions or solving proportions or applying direct variation. So I'm going to find a, for example. I'm going to find a. In this case, a is going to be 2 times 5 divided 4. Okay, remember that when you apply the direct variation strategy or the proportions cross product, you're gonna multiply this times this, 2 times 5, and then divide by the opposite of 5. So it's going to be this one. Look at that, I can divide by 2 here. So I'm gonna get 5 halves. So when x is 2, this point B is going to be at 2 and 2.5. Okay? So this is something you can manage here. Now, what happened with 6? So I can do direct variation. So B is going to be 6 times 5 divided by 4. So I can divide again. 6 divided by 2, 3. 4 divided by 2, 2. 5 times 3, 15 over 2. 15 over 2 is going to be here. That is 7 halves. Okay? So you can see how we can apply direct variation, but only you can apply direct variation if your data, if you represent the data and it's a straight line that crosses by 0, 0. If it's not a straight line, you cannot apply direct variation. If it doesn't cross by 0, 0, you cannot apply direct variation. Okay? Now I'm going to move to another question. It says, how do I exchange any value? Example, dollars to euros. So the question is, how can you apply conversion from dollars to euros? This is again, do it by using direct variation, you know? Because the ratio of coordinates, when you're applying conversion of currency, what you're having is a ratio. Okay, so I don't know how much is $1 in euros right now. Let's see. Dollars to euros. For example, when you put here dollars to euros, it says like 0.92 euros is $1, but let's put like, for example, $1, 1 euro and dollars. Okay, so it's around 108 dollars is 100 euros. So for example, I know that $108 it's the same as 100 euros. So this is something you must know when you convert a currency. When it says $108 is 100 euros, so what it's telling you is just that this is a unit rate. Okay, so the unit rate, if you take dollars to euros, the ratio, so it's going to be 108 to 100. So essentially, you can tell that is 1.08 dollars is 1 euro. Or you can simplify the ratio. If you want to simplify your ratio, it's going to be good. Just remember how to simplify ratios. If you're going to simplify ratios, just divide by common factors. In this case, for example, 108 and 100 both are divisible by 4. So I'm going to divide by 4. 108 divided by 4. Remember that a ratio is just a fraction. Two magnitudes related in quantities as ratios is fractions. So this is the same as putting also 108 over 100. So I'm going to divide by 4. 108 divided by 4 is going to be 2. 10 divided by 4 is 2, and I got 2 left. And 27, 2, and this is just 25. 27 to 25. So it means that any $27 is 25 euros. This is the conversion rate, or you can use this one that has 100. You can choose whatever you want. And let's say that I want to know how many euros are in $250. Okay, now if we use this rate that is here, I'm going to use another. I'm going to use $270. $270. I want to know how many euros are in $270. So you can use or 108, 200, or if you want, as I simplify my ratio, I can use 27 to 25. Okay, now observe that here 27 and I want to know 270, so immediately you can see that I'm multiplying times 10, right? So as this is direct variation, you can just multiply by 10 to get the answer of A. But let's do it by direct variation. A is going to be 270 times 25 divided 27. But look at that, I can just simplify. 27 divided by 27 is 1. 270 divided by 27 is 10. So I just got 250. Okay, and this is how you can convert any currency. So just identify that you have in any currency, when you're converting into currencies, you're gonna have a direct variation. So, and apply direct variation to solve, or ratios and proportions to solve. It's the same thing. Some people will tell me, but I can add. No, it's multiplying. It's multiplying what you can do. Okay? Because when direct variation, we're using ratios. And ratios are just multiplications of fractions or unit rates. Okay, that's it. And this is how you can compare prices, of course. This is the way in which you can compare prices. If you want to compare prices, okay. I guess that the question is how can I know if you have a better buy? If you want to get a better buy, what I suggest is to have the ratio, the unit rate. Okay? The unit rate. What is the unit rate? That's the question. What is a unit rate? Is there any chance I can just erase everything? No. Okay. The unit rate is the way in which you can compare prices. If you go to a supermarket here in Colombia, we must have, or supermarkets must put the unit price. And what means the unit price? That they're going to sell you some price, some quantity, but they have to tell you how much it costs, the unit of whatever they're selling. For example, let's say that they have rice. Let's say that they tell you here that sorry, 500 grams of rice cost, let's say that it cost $1.50. Okay, and this is option A. And in option B, they tell you that 600 grams cost, I'm going to guess a number, $1.80. Okay, let's say that you have these two options and you want to know which one is the better buy, which one it's better for you to buy. Okay, maybe you can guess, maybe you can tell, okay, what happened if I use H1, but the best way is that you create the unit rate. the unit price. So in this case, the unit price is just taking the amount of money, the ratio of the amount of money to the amount of grams. Okay, this is the unit price in this case. So you just need to get the ratio of $1.50 to 500 grams, or the amount of $1.80 to 600. Now there are many methods to compare rates because rates are fractions. You can see this as a fraction, 1.50 over 500 or 1.80 over 600. Okay, now in strictly terms, this is not a fraction because this is not an integer, but I can convert it as a fraction if I multiply, for example, by 10. If I multiply by 10, I'm gonna get 15 over 500, 5,000. And if I multiply by 10 this one, I'm gonna get 18 over 6,000. And I can, if I want, I'm just giving you example. If I can just simplify these two fractions. So 15 over 5,000, it's gonna give me 3 over 1,000. I divide by 5 both, and here 18 over 6,000. I'm just going to divide by 6. I know that I can divide it by more terms, but I'm going to divide it by 6. It's gonna give me 18 divided by 6 is 3, and 6,000 divided by 6 is going to be 1,000. And observe that in both cases I got the same fraction. So as I got the same fraction, it means that the unit price is the same. So they cost the same. This is what I can do just by checking unit price. Now the other option to test it is that you compare both fractions or both ratios. I prefer to tell ratios than fractions because in this case we have ratios. When you get a fraction is when you have the ratio in simplest form, or when you have the ratio with two integers. In this case we don't have two integers. So I'm going to put one ratio, 1.50 over 500, and I don't know which one is equal or greater than. I'm going to put greater than 1.80 and 600. If you want to compare two fractions, you have two options, or denominators, common denominators, or you can also multiply denominator with numerator by cross product to get the answer. So I'm gonna get 1.50 times 600, and I want to know if it's greater than 1.80 times 500. Okay, long story short, 6 times 5, 30. 6 times 1, 6, and 3, 9. And I got 600. So it's going to be 1.50 times 600 is the same as 150 times 6. So it's going to be 900. And here, look at, I can multiply by this 100 first. So move the decimal point twice to the right. It's going to be 180 times 5. 5 times 0, 0, 5 times 8, 40, 4, and 900. And look at that, it's going to be the same ratio. Okay, I'm writing in a place you cannot see. But this is the idea. This is how you can compare common ratios. Okay, this is how you can get common ratios, or how you can test unit price. This is how you can get unit price. And the last question of today, I'm not going to do more. Maybe next time I'm going to talk about geometry. I'm gonna leave next Monday for geometry. Let me see if I can erase. Oh God, I cannot erase. Okay, let's open a new one. And the last question is how to get the end term of basic sequences. The basic sequences I'm going to show here is hello. The basic sequences that I'm going to get here are the sequence that is of this form. Let's say any sequence that has this form: 2, 4, 6, 8, 10, goes on. Any sequence of this form, observe that in this sequence, all the time I'm adding by the same number: plus 2, plus 2, plus 2, plus 2. And not only I'm adding by the same number, I'm just starting with the same number that I'm adding. Okay? This sequence is the sequence 2n. Okay? Any sequence that in which you add the same number and you also start with the number you're adding is a sequence of this form. So it's the sequence of the form an. For example, let's say I'm going to put like a more difficult sequence. Let's say that I'm going to start with 0.3, 0.3, then 0.6, then 0.9, then I continue. Observe that in this sequence I'm adding 0.3 all time. 0.3, 0.3, 0.3. And I am starting my sequence at 0.3. So it means that this sequence is an, is 0.3 times n. Okay? So this is the idea of working on these sequences. Let's say that I'm going to put another sequence. Let's say that the sequence is 1/3, 2/3, 1, 4/3, and continue. Look at that in this sequence. I'm adding each time 1/3. 1/3. Yes, 2/3 plus 1/3 is 3/3, that is 1. 1/3. And I start my sequence with 1/3. So it means that this sequence is 1/3 n. Okay, what you need to know about the sequence is that the n is going to tell you the position in your sequence. N is going to be the position. So if n is 1, I gotta go to the first term. If n is 2, I'm gonna go to the second term. And this is what I'm doing. 2 times 2 is 4. The third term, 2 times 3, 6. 0.3 times 4 should give me the fourth term of the sequence, the term that is here. Okay? This is how you can work on sequences. Now, which is another type of sequences, basic sequences you can use. I'm going to open a new one. Another basic sequence you can use. Another sequence you can use is when you have 6, let's say 6, 7, 8, 9. Continue. Observe that in this sequence I'm adding 1 all the time. Plus 1, plus 1, plus 1. And the term that you start is not 1. Okay? So, okay, here you're talking a lot. No problem. 6, 7, 8, 9, that's okay. So you have plus 1 every time. Now, in this sequence, when n equals 1, I got 6. When n equals 2, I got 7. When n equals 3, I got 8. When n equals 4, I got 9. Look at that. As the distance is 1, I just need to add to my term n the same number every time. Plus 5, plus 5, plus 5, plus 5. So my sequence is just going to be n plus 5. These are the sequence of the form n plus a. So how can I identify the sequence n plus a? Observe that you're adding 1 each time to each term. And after you observe this, you can do the list of the n term 1, 2, 3, 4 and identify what is the number you're adding. Identify what is the number you're adding. This applies for any sequence. Look, I'm going to put an example with decimals. Let's say that I have 0.3, then 1.3, then 2.3, then in this sequence, I'm adding 1 each time. Look, 0.3 plus 1 plus 1. So what I'm going to do is to list my n values, 1, 2, 3, and I need to identify what is the number I'm adding here to get 0.3. 1. If I take 1 and subtract 0.7, I'm gonna get 0.3. So what I'm doing is subtracting 0.7. So my sequence in this case is n minus 0.7. Here the n term is going to be n minus 0.7 because you have 0.3, then you add 1 to get 1.3, then you add 1 to get 2.3. So I know that it's going to be of the form n plus a. And I want to find a, this term that you're adding or subtracting. So you list the n's, 1, 2, 3, 4, 5, and for every term, for 1, the first term, I need to subtract 0.7 to get 0.3. The second term, for 2, I have to subtract 0.7 to get 1.3. So it's the number you're subtracting all the time. So look at that. In this case, we have seen two sequences. The first sequence is the sequence of the form a times n, that you're adding all the time. Look at that. This sequence is simple. You start with a, and then you're adding all the time a. Adding all the time a. This is why it's an. And the other sequence is n plus a, that you start with a number and you're adding one by one. Okay, this number depends on a, the number you're adding each time to your list of n terms. Something that I recommend if you're learning sequences and you need to work out on the n term. Something I recommend, let's say that I'm going to put in the sequence, let's say that the sequence is a simple sequence, 6, 12, 18. Let's put it with negatives. 18, 24. So what I suggest you is to put here, above your sequence, put the terms n. 1, 2, 3, 4. And if you don't want like to memorize the strategy of adding each time, you can also try to find out what is the operation you're doing to the numbers 1, 2, 3, 4 to reach the numbers 6, 12, negative 6, negative 12, negative 18, negative 24. So in this case, you're multiplying times negative 6. So the sequence is going to be negative 6 n. This is another way to do it. But in this case, you're adding 6 all time. Adding 6 all time. So it means it's negative. Sorry, it's not adding, it's subtracting because it's negative 6. We're subtracting all time. So you have the negative 6n. Or let's say that the sequence is negative, let's say that the sequence is negative 6, negative 7, negative 8, negative 9. So I'm going to list the nth, the sequence n, 1, 2, 3, 4, and I want to identify what happened to 1 to get negative 6, to 2 to get negative 7, so on and so forth. Okay. Okay, this is a little bit, I shouldn't put this one. This is not the sequence I'm talking about, although it could be done, but maybe the sequence I was thinking about was -6, -5, -5, -4, -3. So look at that, I'm adding each time 1 in my sequence, but here I can identify that I'm always adding or subtracting the same number. In this case, I'm subtracting 7. So as you're always subtracting 7, you can tell that your sequence is n minus 7. Okay, and this is just the session of today, answering questions that you have about basic mathematics. I'm going to do every Monday this session working on basic mathematics. If I have time, I will do later another about physics. But for today, it's enough. We're going to see more about basic mathematics next Monday. Leave your questions. Could be here in this video, could be by any of my social media, or by any media you can. Okay, see you. I hope you have an excellent Monday, and remember that Monday is the best day of the week. Bye bye, have a nice day. I hope I help you understanding some topics of mathematics. See you, bye.